Hi, I'm Shivansh Inamdar from the University of Pennsylvania and Nimble Robotics, and today I'm talking about task-relevant depth quality metrics for suction grasping. So this paper is about how we evaluate depth methods for suction grasping, and here's the finding. If you look at RMSE, the raw depth sensor wins by 2 to 3 times, but it loses on every task-relevant metric we tried. And the reason is standard metrics reward pixel accuracy, but suction grasping needs local geometric coherence. Suction success really comes down to three things at the contact patch: flatness under the cup, normal accuracy, and completeness near the boundary. But the problem is that we pick depth methods based on benchmarks that don't actually predict any of these. So we tried to evaluate depth directly in grass locations, independent of any planner. We came up with 4 metrics, all grounded in prior contact mechanics work: contact patch planarity error, surface normal angular error, contact patch completeness, and grasp wrench resistance error. And here's a qualitative comparison. The top is the full scene and the bottom is a zoom into the contact patch. The sensor is noisy with holes. The learned methods are smooth and complete. Worse on RMSE, but better for actually forming a seal. And here are the results. Our data is from GraspNet 1 billion, looking at 1200 images and 3 depth methods. And what we can see here is on the standard metrics, RealSense wins. On every task-relevant metric, a learned method wins. And here's a quick at-a-glance view of a slope chart. And what we really propose here is a hybrid pipeline. Pixel accuracy and seal geometry are just completely different things. So we can use the sensor depth for a collision-free approach. You need the metric accuracy there, and use the learned model for evaluating the seal at the contact patch itself. Just going over this quickly, we need to validate versus suction nets, S-seal, and S-wrench, and do physical bin picking experimentation. Thank you so much.